2.5. What are the types of pure substances? On the basis of their chemical composition, substances can be classified either as elements or compounds. 2.5.1 Elements. Robert Boyle was the first scientist to use the term element in 1661. Anthony Laurent Lavoisier, 1743 to 94. A French chemist was the first to establish an experimentally useful definition of element. He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reaction. Elements can be normally divided into metals, nonmetals, and metalloids. Metals usually show some or all of the following properties. They have a luster, shine. They have silvery gray or golden yellow color. They conduct heat and electricity. They are ductile, can be drawn into wires. They are malleable, can be hammered into thin sheets. They are sonorous, make a ringing sound when hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature. Nonmetals usually show some or all of the following properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Examples of nonmetals are hydrogen, oxygen, iodine, carbon, coal or coke, bromine, chlorine, etc. Some elements have intermediate properties between those of metals and nonmetals. They are called metalloids. Examples are boron, silicon, germanium, etc. More to know, the number of elements known at present are more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, mercury and bromine. Elements gallium and cesium became liquid at a temperature slightly above room temperature, 303 K. 2.5.2 Compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. What do we get when two or more elements are combined? Comment this. Activity 2.10. Do this. Divide the class into two groups. Keep 5 grams of iron fillings and 3 grams of sulfur powder in a china dish to both the groups. Group A, mix and crush iron fillings and sulfur powder. Group 2, mix and crush iron fillings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. Groups 1 and 2, check for magnetism in the material obtained. Bring a magnet near the material and check if the material is attracted towards the magnet. Compare the texture and color of the materials obtained by the groups and carbon disulfide to one part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to the other part of. The material obtained. Note, teacher supervision is necessary for this activity. Perform all the above steps with both elements iron and sulfur separately. Comment this. Table, mixtures and compounds. Mixtures, compounds. 1. Elements or compounds just mix together to form a mixture and no new compound is formed. 1. Elements react to form new compounds. 2. A mixture has a variable composition. 2. The composition of each new substance is always fixed. 3. A mixture shows the properties of the constituent substances. 3. The new substance has totally different properties. 4. The constituents can be separated fairly easily by physical methods. 4. The constituents can be separated only by chemical or electrochemical reactions. Now answer. Comment this. The gas obtained by group 1 is hydrogen. It is colorless, odorless and combustible. It is not as wise to do the combustion test for hydrogen is the class. The gas obtained by group 2 is hydrogen sulfide. It is a colorless gas with the smell of rotten eggs. You must have observed that the products obtained by both the groups show different properties. Though the starting materials were the same, group 1 has carried out the activity involving a physical change, whereas in case of group 2, a chemical change, a chemical reaction has taken place. The material obtained by group 1 is a mixture of the two substances. The substances given are the elements, iron and sulfur. The properties of the mixture are the same as that of its constituents. The material obtained by group 2 is a compound. On heating the two elements strongly, we get a compound which has totally different properties compared to the combining elements. The composition of a compound is the same throughout. We can also observe that the texture and the color of the compounds are the same throughout. Thus, we can summarize the physical and chemical nature of matter in the following graphical organizer. Matter, solid, liquid or gas. Pure substance, mixtures, no fixed composition. Pure substance, element, compounds. Mixtures, homogeneous, heterogeneous. Elements cannot be broken down to simpler substances. For example, copper, oxygen, iron, hydrogen, mercury, etc. Compounds have fixed composition, can be broken down into elements by chemical or electrochemical reactions. For example, water, methane, sugar, salt, etc. Homogeneous, uniform composition. For example, sugar in a water, salt in water, sulfur in carbon disulfide, water in alcohol, etc. Heterogeneous, non-uniform composition. For example, sand and salt, sugar and salt, water in oil, etc.